This conference will now be recorded.
All right. Hello, everyone. Welcome to SECOORA's webinar series, Coastal Observing in Your Community. SECOORA is hosting this webinar series to discuss, highlight, and raise awareness about coastal ocean observing activities in the southeastern United States and beyond. My name is Emily Noakes, SECOORA's Communications and Engagement Specialist, and I will be moderating the webinar today. SECOORA is the regional coastal ocean observing system for North Carolina, South Carolina, Georgia, and Florida. We aim to collect data and create tools that support human populations, coastal economies, and a healthy, sustainable environment. We are one of 11 regional associations that make up the Integrated Ocean Observing System, also known as IOOS. Our mission is to bring people, technology, and data together to facilitate collaborations, projects, and knowledge sharing to ensure coastal ocean resilience, safety, and a thriving blue economy. If you would like to learn more about who we are, what we do, and why we do it, please feel free to scan the QR code or type in SECOORA.org to visit our newly designed website that I am quite proud of. I think it is very beautiful. And we've got plenty of information on there if you'd like to learn more about us. So we would like to invite you to SECOORA's 2024 annual meeting in Charleston, South Carolina, May 7th through the 8th. Please visit SECOORA.org/2024 annual meeting to learn more and register. The deadline to book your hotel is April 7th, and the registration deadline is April 23rd. If you have any questions, please email communications@secoora.org, and I will get those answered for you. So another quick update, GCOOS, the Gulf of Mexico Coastal Ocean Observing System, and SECOORA are teaming up on a webinar series focused on establishing collaborative opportunities among MBON, the U.S. Marine Biodiversity Observation Network, GCAN, the Gulf of Mexico Coastal Acidification Network, and SOCAN, the Southeast Ocean and Coastal Acidification Network. The first webinar will kick off on Thursday, April 11th at 12 p.m. Eastern Time. The goal of this webinar is to build synergy across the networks to advance science in support of resource management in the blue economy. We will send out a registration link very soon on our own listserv and social media. You may have already received the registration from GCOOS because they will be leading the first webinar in this series. But we will send out a registration link to those of you who are not on GCOOS's listserv very soon. And as always, please email communications@secoora.org if you'd like to be added to the listserv, or if you're not quite sure if you're on there or if the emails are going to spam, just let me know and I'd be happy to work with you on that. All right, so now that we've talked about SECOORA for a minute, let's talk about this webinar. So we highly encourage you to ask questions during the webinar. And for this platform, you can use the chat box to just type in your questions throughout the webinar. And we will address those at the end of Doug's talk during a Q&A session. And if we end up running out of time and we don't get to your question, or if you happen to think of a question once the webinar is over, once again, email communications@secoora.org and I will connect you with Doug. I think that Doug might also be putting his email on his slides, so you're welcome to reach out to him directly, but I would be happy to connect you if you don't feel comfortable initiating that contact. And as always, we are recording the webinar today and we'll be posting the webinar on the SECOORA website, on our webinars page, and we'll also be posting it on our YouTube channel. So we are very excited to be hosting Doug Marcy for this month's webinar. Doug is a senior coastal hazard specialist at the NOAA Office for Coastal Management in Charleston, South Carolina. He has been with NOAA for 22 years, working on flooding and sea level/lake level data decision support tools, and technical assistance. Now, Doug, if you want to go ahead and share your screen, we can get started.
All right.
Looks
Emily,
great.
can you see the screen, and can you hear me okay?
Yes, looks great and sounds
Okay.
great.
Okay, good. Well, thank you, everyone. Thank you to SECOORA for inviting me to speak with you today and be the guinea pig on this new meeting software. It's always a challenge to get everything to work right, so hopefully that continues to happen. Looks like everything's working good now. So what I'd like to do is go through a little bit of climate change 101, kind of at a high level, global climate change and global sea level rise, what's driving sea level rise, what causes it, what's some of the uncertainties with it, and then kind of drill down into the Southeast region, what we're seeing in the data, using some examples locally, and then where we're going in the future with future emission scenarios, global climate models, and then get into some of the impacts we're seeing, and then into some of the NOAA resources and data resources and tools that you guys can use through our Digital Coast platform. So with that, I'm going to keep on going. So now for the sort of climate 101, climate change 101, every 5 years or so, the Intergovernmental Panel on Climate Change, IPCC, puts out an assessment report, and we're actually on our 6th one now. That is driven by kind of the global climate modeling cycle. There's a climate coupled model integration project, CMIP, which is a large group of researchers that work on global climate models together. And when they update and put out new climate model information, then they reassess the impacts of that. So CMIP 6 came out, therefore IPCC 6 comes out, and then we follow up in this country usually with another national climate assessment based on that. We're on NCA 5 right now. It just came out in the last couple of months. Most of the information I'm going to be showing you is from this AR6, and then the information and data and sea level rise information from the science that went into the National Climate Assessment, the fifth assessment. So the AR6 report, we've seen unprecedented numbers. We've seen the highest CO2 concentration in the atmosphere in the last 2 million years. We've seen the fastest rates of sea level rise in the last 3,000 years. Sea level has been fairly static since the last interglacial period, and has pretty much, when society has built, civilization has built along the coast, it was pretty stable, and now it's really starting to change. Arctic sea ice is at its lowest levels in 1,000 years, and glaciers are continuing to retreat at unprecedented levels, more than probably the last 2,000 years. We're seeing changes in temperature in atmosphere and in precipitation. As the air warms, it can hold more moisture. So we're seeing the annual temperature, but not only just the annual, the winter and the summer temperatures going up. In some places, I guess they're going down. And also areas so what we try to say is, yes, there'll be more extremes. So places that are already hot are going to get hotter. Places that are already wet are going to get wetter. Possibly you're going to see more cold areas that get even more cold because of the jet stream kind of being a little bit more unstable. So we'll see these more extreme cold and warm events happening. So this is going to be a significant change coming in the future. And in terms of sea level, we've seen observed sea level trends on the order of, if you look past 100 years or so, around a foot of sea level rise. In most places, and you can see how that regionally is different, right? It has to do with the vertical land motion. We'll talk about how sea level is really relative to your local location with a lot of different factors involved. We also know that looking at the data and the amount of money that the government has had to put out for disasters, we're looking at these $1 billion disaster events, which NOAA captures and records. We are seeing obviously an upward trend. If you look at the numbers around the country, you could make the argument, well, are we having more disasters, or are we just more people are moving into harm's way? And I think it's both. The disasters are becoming more frequent, or the weather events and whatnot, but we're also much more population is living in areas that are hazardous to live in. So it's not surprising you see a lot of the number of events in the southeast and along the Gulf Coast. A lot of these are driven by tropical events. And then as far as costs, Florida, Texas, Louisiana, we've seen, and then of course drought and other things are affecting on the West Coast. So there is a lot of money that is being accumulated in terms of paying for this disaster cost, and doesn't seem like it's slowing down. So when it comes to trying to predict what's going to happen in the future, what the modeling community tries to do is come up with these scenarios. In NCA 4, they were called representative concentration pathways. They've changed the way they're doing that now, and they're called shared socioeconomic pathways. But essentially, they're different scenarios for greenhouse gas. And what this shows is the various scenarios, and then when, if you see the dials down there on the right side. So it shows you where we are now by that little pin. I don't know if you can see my cursor here or not, but the various scenarios is when are we going to exceed global temperature of 2 degrees Celsius compared to now? And you can see based on the different scenarios, obviously it happens sooner with a higher scenario. And that 2 degrees is kind of what scientists have said is going to be a really tipping point with everything, with not only temperature, precip, but also with sea level rise too. So the trick is figuring out the temperature in the future, because that really is what is going to drive sea level change. And in terms of sea level change, I know this is a complicated graphic, kind of did that on purpose. I'm pulling this from a paper from Oppenheimer. There is a lot of factors. You may think, well, it's just, sea level is just one global number. It goes up and down. But in reality, there's a lot of factors that contribute to that, what's going on in your region. So you have, things like the ocean is warming, and that's causing, the volume of the ocean to change, is increasing. So that's the biggest factor that's going on now with global sea level rise. But locally, you have vertical land motion. You have subsidence going up. You have isostatic rebound in some places with glaciers are not there anymore where they used to be. And then on any given day or month, we can also have extreme sea levels with storm surge, wave setup. But all those are hazards are going to keep happening. And then at the background, sea levels is rising. So we're getting more and more events where we're starting to increase the flooding extents, and the thresholds for flooding we're starting to cross way more often. The biggest source of uncertainty comes down to trying to figure out, it's not only in the emissions, how much emissions we're going to have in the future, but how the ice sheets are going to respond. So the big ice sheets like Greenland and Antarctica, there's a lot of factors there that we really didn't study for a long time because they were pretty stationary and pretty stable. Now that they're starting to become unstable and a lot of melting, we're starting to figure out the warming at the bottom of the ice. For instance, this is the Thwaites Glacier. That's also called the Doomsday Glacier. As the water gets warmer, it'll start melting, and you could potentially start having some calving in the front. And if that gets past the grounding line, then this entire glacier will flow faster. So there's this whole feedback loop we're starting to get a handle on, and that's what drives some of the more extreme sea level rise events. We just don't know how that's going to happen, whether it's going to be a linear process. So the uncertainty in the emissions and the uncertainty in the ice sheet rate of melt is really what drives the scenarios to be kind of far apart once you get out to 2100. So this is on the left showing you the future scenarios, and then on the right is the different IPCC projections, the SSPs. So you can see that sort of in the middle range, you're looking at about like between 3 and 4 degrees by 2100 would drive this certain amount, like middle intermediate sea level rise. And again, the range of those are high because we are not quite sure, sort of the worst case could be upwards of 7 feet. We're pretty sure a low rate of, basically just the current trend is not likely either, because we know we're going to be adding more meltwater and increasing the ocean temperature, which is going to cause it to expand. All of this was taken into account when this interagency task force that we were part of, with all these other agencies, that came out in 2022 with the Sea Level Rise Technical Report you probably have heard of. It provides the most up-to-date sea level projections for the U.S., and it was input into the National Climate Assessment. There is also an application guide I would point you to as part of the report. It kind of is more of a breakdown. The report's pretty dense and technical. This provides application for managers to use, gives you sort of information about what the scenarios mean and what's some good risk management approaches to take. We also recently did a takeaways video. It's a really good quick video that, well, I guess it's like 7 minutes or so, but it's a pretty good overview of the tech report if you wanted to show folks that don't have time to read it, which is most of us these days, right? So the main takeaways are that we're going to probably see another foot of sea level rise in the next 30 years by 2050. Most places have already seen about a foot, and that's taken about 100 years to get a foot of sea level rise. So we're talking another foot in another 30 years. So that's going to cause more extreme tides, damaging storm surges, and a profound shift, which I think we've started to already see in the Southeast, where we're going to start having moderate type flooding a lot more often. We're starting to cross these critical thresholds way more often. And so you're seeing more flood advisories, for instance, from the Weather Service occur. And then as we go out into the future, emissions really do matter, and so do the ice sheet melt rates. But so there's this big uncertainty. We could still see 7 feet, but uncertainty after 2100 keeps going out. We don't think we're going to get as extreme as we did back in the 2017 report, where we had sort of an additional scenario, which was an extreme high. We don't think we're going to reach that by 2100, but eventually by 2150 we could. So the uncertainty increases. I'll show you how the uncertainty's gotten better by 2050, but we're also continuing to observations, with this being part of SECOORA's mission. Observations are key, and the more we can observe and longer period of record, we will be able to enhance, because those get used into the future conditions or future predictions. So again, looking at, you saw that picture in the past of the different sea level trends, and when we're looking in the future by 2050, it's the same thing. It's not the same around the U.S. There's different rates. Where we have high vertical land motion rates, you see there in the Gulf, Louisiana, along the East Coast, some hot spots. We're going to see a little bit higher than perhaps on the West Coast and some places in Alaska. And you'll notice that Alaska, everybody says, well, now all of Alaska is not going to have sea level increases, but on the North Slope, that's not true. On the West Slope, there is going to be some sea level rise. It's mostly on the southern end where you're seeing the tectonic uplift, where we may not see a sea level rise there. It might fall because of that. So kind of putting it in perspective, going back, let's say 100 years ago, and we're kind of using our Charleston gauge here. We've been collecting data since 21. We've seen about a 1 foot of sea level rise, and we're going to see another 10 to 12 inches or a foot in the next 30 years, which is really going to cause a profound shift, as I mentioned. So as we go through these different assessment reports and sea level rise reports, we're going to try to continue to do this every 5 or so years. Hopefully, we'll be shrinking the uncertainty here, at least in the short term. So what we're showing here is a 2017 report in the dashed lines, and then you got your most recent report in the solid lines. And so you can see at 2050, all of the scenarios are within about a foot of each other. So we're pretty certain we're going to at least experience that much in the next 30 years. It still gets pretty uncertain as we go farther out, but in the short term, we're getting a better handle on that. We're also able to use historical observations, and this is again some work from the interagency group, NASA, NOAA, others were working on basically an extrapolation going back to 1970 of all the tide gauges and doing it for each region, which I'll show you in a minute, and then extrapolating that out to 2050, kind of like a best fit curve to see where are we headed and is that matching up with what the global climate models are telling us. So as you go through this sort of continuum, we have what we know has happened, observational data, truth, if you call it that. The data shows it is rising. Then we go out to 2050, we have some process uncertainty, but we kind of know and understand what's happening. So we're more certain, but as we get farther out, again, it comes down to emissions and the ice sheet disintegration and how fast that's going to happen. So drilling down, just to give an example, this is for Charleston. We've had the gauge around here since 1921 without being disturbed. It actually was there earlier and it got moved. If you draw a regression line through that, through the monthly data, then you get basically 1.14 feet in the last 100 years. But what you notice is that at the end of this time series, probably since about 2005 or 2010, you see a little bit of an increase in the slope of that. So the rate is starting to fluctuate. Now, look, if you look in the past, it has as well. There's discussion about 10-year cycles of the Atlantic Oscillation, things like that, Gulf Stream slowing down. Then there's the issue with you've seen some papers about the nodal cycle, which is the cycle the moon takes. So you have, when the moon's a little bit closer, it causes tides to be higher, and that can cause the same thing. But overall, if you do this sort of extrapolation for the whole Southeast, you can see that we're somewhere in between intermediate and intermediate high is what when you extrapolate the data, the best fit curve out. So looking at about 1 to a little bit above 1 foot by 2050. So that's going to cause high tide flooding to increase. It already has. Nationwide, we used to have an average, and this gets averaged between all the gauges in the country, but about 2 days. We get a lot more here, but on the Southeast, now since 2000, in 20 years, we've seen almost twice that, and we're expecting to see almost up to maybe 20 times that. So these high tide flood events are going to continue to increase. What that looks like, and if you go back into the record, and this is, we're pulling in data from our sister office, Tides and Currents co-ops. They're counting the number of times we pass certain thresholds. The one we use here in Charleston is 1.87 feet above mean high water, and we map that in this red zone here. It's minor flooding, and we count the number of times. So you can see in the graph over here on the left how many more times we've seen. So we're getting up towards within 15 or 20 times a year now. And that's the NOAA threshold. If you follow Weather Service, uses a slightly different threshold for flooding. And their numbers are even higher because it's a slightly lower threshold, but their numbers indicate the same thing. Our sister agency or office co-ops has also been working on monthly high tide flooding outlooks. So we're trying to predict when are we going to see these high tide flood events. They're related to the perigean spring tides, but they're able to do that monthly now and give you a calendar. It gives you possible days that we're going to experience high tide flooding. They're also looking at kind of a yearly and also based on a different sea level projections, you can see how many more high tide flood events we will have by 2050 using some of the scenarios I just showed you. So what are the impacts going to be? We are already starting to see the impacts in many areas. I think of it as sea level is just exacerbating the problems we already have. We already have storm surge and flooding. We already have wave issues set up, coastal erosion, extreme rainfall when we have high tides at the same time as rainfall in coastal cities. It has a difficult time draining because of the tide getting into the stormwater pipes. So sea level going up is just going to really increase a lot of the hazards we already have. The groundwater table, not only with saltwater intrusion, it's going to potentially contaminate drinking water wells, but also and the saltwater wedge coming forward will increase the water table, the freshwater lens on top of that, particularly in places like Florida, where it's so porous. The water table is going to be pushed up towards the surface, so we'll not be able to accept any rainwater, which will cause even more runoff. And then the whole floodplain, the coastal floodplain as we know it, is going to kind of march landward. So the maps we have to designate our coastal flooding hazards now that we use, for instance, for our flood insurance rate maps from flood insurance studies, those are based on like current conditions and don't include sea level rise. But as the floodplain migrates and comes inland, the floodplain is going to change. So that is going to start impacting. So people that didn't have to worry about it and have flood insurance now eventually in the future will. So we're starting to take a look at that through things like the Federal Flood Risk Management Standard, which is mapping where the future floodplain will be and trying not to put federal investments in those areas if we can help it. And if we do, make sure it's built resiliently and adaptable. And when you get to coastal cities, many like Charleston, Norfolk, others that deal with this, you have extreme rainfall at the same time as you have increasing water levels. And so the water just can't drain. It backs up unless you do storm, backwater valves and things to protect. And a lot of the cities are starting to do that. Charleston has been investing a ton of money into pump out stations and a drainage network to try to push the water out, put more head on it, if you will, because it's a gravity-fed system, and when there's less difference between the where the water comes in the inlets to the outfall, then it won't drain as fast. So getting now more into resources that our office has been working on. Hopefully many of you are familiar with the Digital Coast. It's basically a website, yes, but it's also a group of folks that kind of advise NOAA on, or at least our office on, basically what our tools and our products meeting the needs. So we ask, it's basically a constituent-driven platform. So we're constantly trying to get feedback through a service delivery model where we ask up front, is this what you need? And we get feedback, and then we build it, and we provide the data, and then we keep asking throughout that process. So, and we provide it on a website. We have a lot of different products. This is what the website looks like. I'll just go ahead and go into it. We have a lot of data. We have over 500 terabytes of elevation data. So we have LiDAR data, land cover data, which is getting higher and higher resolution, ortho imagery. We have a lot of web mapping services and a linking to a lot of other coastal data sets as well, not just NOAA. We have a couple of ways to grab that data. You can go through a data registry, or you can go right into our data access viewer. This is an example of going and pulling out elevation data. So you can pull the LiDAR data that we have available for different areas and customize that and then download it for your needs. We have a ton of different tools as well, everything from land cover atlas to look at land cover change. We have coastal county snapshots, which looks at, for the coastal counties, things like flooding and sea level rise risk, historical hurricane tracks. One of our example kind of flagship tools is our sea level rise viewer. It's sort of a screening level, nationally consistent viewer based on the best available LiDAR data and VDATM model. VDATM is a model that models the tidal surfaces. So we map mean high water because the tidal ranges change as you go across different parts of the country. And we're always updating that with best available DEMs, and it all can be downloaded. And we actually are, right now we have 1 foot mapping, but we're going to be changing that to half-foot mapping soon. So we'll be able to see that and compare to both the 2017 and the 2022 sea level projections. This viewer gets used a lot. Tybee Island, for instance, use it in their adaptation plan, looking to try to elevate the causeway because it gets cut off during high tidal flood events and storm surge. New Jersey Adapt and the New Jersey Flood Viewer, we provided all of our code for our viewer, and the same kind of methods for mapping. We provide all of our DEMs to Climate Central for their Surging Seas application. We provide all of our digital elevation models to the Hurricane Center, National Hurricane Center, for their storm surge modeling and mapping, and a lot of others that use our data too. We have an adapting stormwater management for coastal floods tool, which is pretty neat. It goes through this whole idea of coastal flooding and what sea level rise is going to do to increase coastal flooding, and how stormwater systems weren't really designed for that, and how they can be retrofitted. Specifically, it goes into these critical thresholds and uses the sea level rise viewer data to show you areas that are going to be impacted. You can enter your own thresholds in and figure out when is that threshold going to become like a daily occurrence, and how is it going to change the flood frequency. We're actually working on another tool right now with some bipartisan infrastructure money to kind of take elements of this tool and build a sea level calculator that's going to provide even more functionality. We have a flood exposure mapper that kind of combines all of these different coastal flood hazards into one, and gives you like a composite map. You see the zones there, and you can save the map. You don't really have to have a GIS. You can just save these images, but it also has the individual hazards in there as well. So you can click anywhere. The redder areas are going to be areas that are susceptible to more inundation hazards, closer to the flooding source. So this is an example. You pick a spot and it tells you what you're in a flood zone, a FEMA flood zone, high tide flooding, sea level rise, all of those. We also have a ton of different learning resources. We have, for this purposes, we have a coastal inundation mapping course that we teach. It's a 2-day GIS course, but we have a ton of online courses as well through our Digital Coast Academy. We have a lot of stories from the field where it demonstrates the application of our data, not just downloading the data, but how the data was used to answer a certain management problem. And we've consolidated a lot of coastal inundation resources on our topics page. So all the technical reports and things I was talking about earlier are available on that. So I encourage you to go there. And with that, I will stop and we'll do questions.
Thanks, Doug. That was really great. And yeah, if anybody has any questions, please feel free to put them in the chat. We'll give you a minute to type them in and formulate them. And looks like we've got one coming in. Yeah, so we have a chat from Alyssa. As far as land sinking, is that data considered in the projections of sea level rise impacts?
Yeah, I'm trying to figure out, should I stop sharing, or maybe I should. Yeah, I'll stop.
You can just, yeah, it's up to you. It's whatever you want to do.
Yeah, have I stopped? Okay. Yeah, so it's a good question. Short answer is yes. The vertical land motion rates that are used, they are baked into the sea level projections. They're called a background rate, but if you download the data file from the 2022 technical report, there is a background rate for every tide gauge, and that's been extrapolated to this 1 degree grid that was also provided. So it uses the tide gauge VLM rates, vertical land motion rates, and then extrapolates that to this 1 degree grid. So that rate gets baked into the projection information. Now, that's interpolated from gauges. There are places where there's a lot of work going on to make those a little bit more refined or granular. For instance, in Washington State, a colleague, Ian Miller, has been working on different rates of subsidence and uplift in Puget Sound have caused different VLM rates. So this idea of getting better regional VLM rates is something that the research community really wants to try to do, because it does make a big difference when you're talking about long-term projections. So they're using technology called INSAR, which is basically satellite-derived deformation information that gets, it's a satellite data set that gets compared to itself over the years, but we've only got about 10 or 15 years of data. But you can start to see land motion in that data set. The big question is that going to be permanent land motion rates that we can put into long-term scenarios, because that does make a difference. But that's something that we're trying to get a better handle on for sure.
Okay, so we have a few more questions coming in. So we have one question from Mary along with a follow-up question. So we'll start with the first question that they asked. What concerns should we have about proposed undergrounding of electrical grid in land that was previously salt marsh?
Good question. Everybody says the best way to reduce power outages is to put power underground. And I'd say that's probably mostly true because, you know, wind hazards, especially with all the trees and whatnot we have, cause a lot of our power. But there is long-term degradation that will probably happen. It just depends. I'm not an electrical grid kind of guy. I don't know much about it. I just know that when they bury them, it requires you to bury them in conduit that is, you know, resilient, like whatever it is. It's plastic. What's that? Kevlar plastic or whatever, so that it won't degrade and get into the wires and things like that. So, but that is something that needs to be taken into account, you know, where we're looking at future power grid. I know that some of the other agencies with the BIL money they've received have been doing that for like broadband and things. They're looking at some of the impacts. Let's not put a broadband cable through an area that is going to be flooded, because it may you know, get undermined and scoured out and damaged. So that is definitely something to think about.
Okay, so Mary's follow-up question is, can the SLR tool be used as a proxy for storm surge inundation visualization?
So that's a good question. It has been used that way. Matter of fact, we have colleagues up in the Northeast that they don't, that's not necessarily for hurricanes, but for nor'easters. They do look at. So well, here's how I would say. If you know the forecast for storm surge is going to be a certain elevation, let's say 2 feet above mean high water, and you look at our viewer and you want to see what 2 foot looks like at your location, it will be pretty correct. The issue is with storm surge on a hurricane size storm, the majority of the surge is on the right side of the storm as it comes in, so the northern part of the area is going to get higher sea level than the southern part. So you can't just generalize and say, oh, the whole area is going to get 5 feet. But if it's forecast to be a certain level, and what the Hurricane Center does is actually produces a potential storm surge map, and they basically look at the model runs for the probabilistic storm surge, and then they map that on a 30-meter DEM and show you the areas that are likely to be impacted by 0 to 3, 3 to 5, I think it's 0 to 3, 3 to 6, 6 to 9 feet. And so they provide those maps and gives you a likelihood. So it's the same kind of idea, it's based on the same data. But for a proxy of what's going to happen, if you find out in Charleston Harbor, for instance, that we're going to have let's say an 8-foot tide, that's relative to mean low water, and then you want to figure out what that is and convert that to mean high water, and then look at our viewer, yeah, it's pretty accurate. I can tell you that because I use it here at our office, which is right on the Cooper River. It gets it right on. And we can actually see our parking lot flood during high tide events. It shows that on our mapping.
So it's interesting you mentioned the Charleston area, because we have a question from Alan regarding the Charleston area. So in the Charleston area, are there any groups monitoring where high tide flooding occurs, like collecting observation data and photographs? And how does that information and data get collected in the region?
That's a good question. And there are a couple of groups that I can think of. There's one called MyCoast. If you Google MyCoast, MyCoast, that is a application you can You can actually download and collect information. You go out and take pictures at high tide flooding, and it'll go and capture what the tide was at the time and do like a photo geolocation, upload the photos, and you can go in there and you can look at past events. That's sort of like a citizen science collection. And then I know there's other sensors out there. So we have our NOAA tide gauges, yes, but then I know that SECOORA, for instance, is funding a lot of smaller and cheaper sensors that can record water levels, and that gets like sent to a database, and that can also be used. So there are a lot of different data collection programs in effect. I know that the NERS, the National Estuarine Research Reserves, also have a whole system SWAMP, that a database that can be used as well with water level information. So yeah, there's a whole host of them. The ones that, does that make it into a larger like NOAA database? That we're trying to work on that. We're trying to work on some being able to use sort of more of the citizen science and these other sensors in the overall, especially in the modeling sense, because where we're headed is to try to produce, similar to our VData model, we're trying to produce a gridded information. Instead of just getting information at the tide gauge, you would be able to get information on like a 500-meter grid, and that's going to be supplemented with calibrating to better observation data to do that. So that's kind of where we're headed. So that it'll be like a virtual gauge. You can click anywhere and get that information.
Right, so it looks like we have one more question from Joy regarding the SLR viewer. What is the most recent year of LiDAR that you are using for the DEMs?
Well, I guess the question is for, I'm not sure if that's specifically for South Carolina, but we use the best available. So whenever there's a new collection, we usually know about it because we have NOAA is part of the several agencies that are part of the three-dimensional elevation program, 3DEP. We know when that data has been collected because we collaborate on that, and then as soon as we get access to it, we try to update. So for instance, we just finished up updating Florida after Hurricane Irma collection. First time the Everglades were really mapped. I believe in South Carolina, we have, it's been a while. I think Horry County maybe has new data, but for Charleston area, I think we're still relying on 2017 data, but that's because we haven't had any new like countywide collections. But when there's collections that happen after storms and things like that, through shoreline mapping with our National Geodetic Survey, we do try to incorporate that. So if you go to our viewer, there's an data update button on there, and it shows you, we have a whole long list going back several years of when we've updated certain areas. And it's, like I said, it's depending on where you are. But you can pretty much count on, if it's collected and it becomes available publicly, that we'll eventually get it in there and update our DEM. So it's definitely evolving.
All right, so I think that was our last question. So I'll fill the gap for a minute in case anyone's still thinking. We are recording this, and we will be posting it on SECOORA's YouTube channel along with our website. And that should be available by the end of the day today. And yeah, if anyone's interested, I was going to stop recording and open it up where people could turn on their mics and cameras if you wanted to say hello or tell Doug thank you for being our speaker. So thanks everybody for joining today, and I'm going to stop recording now.